So what does it mean to be dilated? You know, you think about your pupils, when they're dilated, they get really big, right? Now, I've never seen one this big, but your pupils enlarge and then reduce in size, and they adjust, you know, to light, to when you're maybe telling a lie, to things that surprise you. That causes your pupils to dilate. Well, dilation is a transformation that changes the size but not the shape of a figure. So translations are slides, reflections or flips, and rotations, which are like turns, are transformations that do not change the size or shape, but a dilation does change the size. It can reduce or enlarge the figure, and the way you're going to know if it reduces or enlarges is by the scale factor. A scale factor describes how much a figure is reduced or enlarged. If it's between 0 and 1, the figure will be reduced down, but if it's greater than 1, then the figure will be enlarged. It'll get bigger, okay? So fill in those blanks, make sure you have your target. Let's practice identifying dilations first. I'm going to give you a little, an easy way, a hint on how to do this. Draw a line that connects each pair of corresponding vertices for each figure. If the lines intersect at one point, then the transformation is a dilation, and this point is called the center of dilation. So let's try this. Let's look down at A. Tell whether each transformation is a dilation. If so, label the center as point O. Let's first draw lines that connect each pair of corresponding vertices. So this is the top left corner of this rectangle. I'm going to connect that to the top left corner of this rectangle, and I'm going to continue this line on. So make sure that it ends up that these two are connected, and then I'm just continuing it on. Doesn't matter how far, but extend it out there a little ways. Then use your straight edge or your ruler, connect the top right corner of the rectangle to the top right corner of this bottom rectangle, and again, just continue that line on. We're hoping that they're going to intersect at one point, so you want to extend it out until you're going to reach that intersection. Let's connect the bottom right vertex with the bottom right vertex down here, and the bottom left vertex with the bottom left vertex. Is this a dilation? Well, do all the corresponding vertices, are they connected but lines that intersect at one point? Yes. So this is a dilation. You may have done something like this in art class with a perspective drawing maybe. Your center of dilation here is O. When you draw perspective drawings, a lot of times your point that you're dilating by might be off on the horizon. But this allows us to create a three-dimensional figure. So that is a dilation. Great. With B, let's try this again. Again, connect corresponding vertices. So you want to kind of predict which way it's going to connect. You know, I could draw a line like this and move it around until I'm touching the vertices, going out on both sides. But you have to figure, where would my center of dilation be? Is it going to be on the left of this drawing or the right? As you go on and connect the other vertices, are they going to intersect over here on the left, or are they going to intersect over here on the right? Well, they're going to intersect on the side that's the smaller one, right? Because this line's going to tip up this way. If I extend it out over here, that's getting way too far, and we can even show that. But those aren't going to intersect over on the right. They're actually getting farther apart. So, okay, these two vertices are lined up, and then let's connect R prime to R. And when we do that, we actually already connected P prime to P. Those are corresponding vertices. So when we look at this,